Have you ever looked up at the night sky and wondered if we're truly alone? What if there are thousands, maybe even millions, of intelligent civilizations out there just waiting to be discovered? Well, back in 1961, an astronomer named Frank Drake asked the same question, and he came up with a formula to help us figure it out. It's called the Drake equation, and today, we're breaking it down in the easiest way possible. The Drake equation is a formula that estimates the number of civilizations in the Milky Way that could potentially communicate with us. It looks complicated at first, but don't worry, it's actually pretty straightforward. So here's the equation, up on the screen there. Now let's break it down piece by piece. So our star is the rate at which new stars are born in our galaxy. More stars mean more chances for planets to form. FP is the fraction of stars that actually have planets. Spoiler alert, most of them do. NE is the number of planets per star that could support life. FL is the fraction of those planets where life actually appears, because just having water doesn't mean life will pop up. FI is the fraction of life-bearing planets that develop intelligent beings. FC is the fraction of intelligent civilizations that develop technology to send signals into space. And L is the length of time these civilizations send out signals before disappearing. Multiply all those numbers together and boom, you get the number of civilizations out there that we might be able to detect. Sounds great, right? The problem is, we don't actually know the values for most of these variables. Some of them, like how many stars form each year, we can estimate pretty well. Others, like how many civilizations are out there broadcasting radio waves, not so much. That's why scientists' estimates for the number of civilizations vary wildly, from one, which is just us, to millions. Even though we don't have all the answers, modern astronomy has made huge progress in filling in some blanks. Here's what we do know. Exoplanets are everywhere. When Frank Drake first proposed his equation, we hadn't found a single planet outside of our solar system. Today, we've confirmed over 3,700 exoplanets, and there could be 160 billion in the Milky Way alone. And some planets might be just right. Scientists have found planets in the so-called Goldilocks zone, not too hot, not too cold, where liquid water could exist. As of 2018, at least 53 planets seem promising for life, and 13 of those are strong candidates. Red dwarf stars could hold clues as well. Some of the closest planets to us, like those around Proxima Centauri and the TRAPPIST-1 system, orbit small red dwarf stars. These planets could be habitable, but red dwarfs also have violent solar flares that might wipe out life before it has a chance to thrive. Scientists are still figuring this one out. If the Drake equation suggests there should be thousands or millions of civilizations, then why haven't we heard from any of them? This is known as the Fermi Paradox, the idea that, statistically, we should have found aliens by now, but we haven't. There are a few possible explanations, though. Maybe intelligent life is rare. Even if life is common, becoming advanced might be super difficult. Maybe civilizations don't last long. If they wipe themselves out through a nuclear war or a climate disaster or whatever, they wouldn't have time to contact us. Or maybe they're just not interested in us. What if advanced aliens look at Earth like we look at ants? They might not think we're worth talking to yet. And lastly, maybe we're not looking the right way. Our technology might not be advanced enough to detect their signals. But the search for alien life is far from over. New telescopes like the TESS and the James Webb Space Telescope are scanning the skies for more Earth-like planets. Future missions might even analyze atmospheres for signs of life. And who knows? Maybe one day we'll get a message from the stars. So what do you think? Are we alone in the universe? Or is intelligent life out there waiting to be found? Let me know in the comments below. And if you enjoyed this simplified breakdown of the Drake equation, don't forget to like, subscribe, and hit that notification bell for more mind-blowing space content. Until next time, keep looking up. See you on the next one.